Hi all, welcome to Math 411-511, a course on group theory. This entire semester we're going to be talking about groups. Informally, a group is just a set with a well-behaved operation, and this is going to turn out to provide an algebraic framework that's applicable in a lot of different settings. Now there are many examples of groups. I've listed two examples here, and they range from familiar objects like the integers under addition, which is something that we've known about for a long time, to objects that are maybe a little less familiar, for instance, the symmetries of an equilateral triangle, where the operation is just composition of symmetries. So groups have a lot of applications, including those to cryptography and combinatorial and statistical design. If you're a high school mathematics teacher and you're taking this course, perhaps the biggest thing that you might get out of this course is a deeper understanding of the familiar settings in which we perform arithmetic. Here I've listed some important aspects of our course. First of all, this is a theoretical mathematics course, and that means that many of your homework and exam problems are going to ask you to prove things. All of you are going to be doing reading, you're going to be watching some videos, you're going to be doing homework problems, and you're going to be taking exams. However, your weekly sort of class experience will differ depending on which section of the course you're enrolled in. If you're in Math 411 or if you're in Math 511 Section 1, then we'll be having twice weekly classroom sessions. On the other hand, if you're enrolled in Math 511-880, then this course is going to be an asynchronous online course with weekly modules. Now, our interaction there will be through Zoom sessions, and I'll be contacting you with more details about that. It is assumed for all sections of the course, it's going to be assumed that you will have read ahead and watched the videos in order to be prepared for our discussion and interaction. Now, probably the most important thing that you can do in this course is to devote time to careful reading of the textbook and to time for homework. Those are of really paramount importance. Your interactions with me, I really enjoy interacting with you, and those interactions can be valuable, but I think the most valuable things are the things that you do outside of my presence. And that definitely involves reading and spending time on homework. And then finally, there's pressure involved here, of doing all of these things and receiving grades. And, it's sort of a long slog this semester. But let's just try to enjoy ourselves and enjoy this material. It's extremely interesting material, and hopefully at the end of the day we will have found this to be a rewarding experience. Here now are a few technical considerations regarding the course. First of all, you're going to be doing homework throughout the semester, and one way to make your homework legible to yourself and to me is to typeset your homework. A good way to do that is to use Overleaf, which is an online LaTeX editor and compiler. If you know what it is and know how to use it, that's great. If you've not heard of it before and you're interested in trying it, I just recommend that you Google Overleaf and see what it's all about. Now, it's optional, of course. You can always write your homework solutions by hand. That's perfectly fine with me. But I encourage you to consider using Overleaf. Second, you're going to be, no matter which section of the course you're in, you're going to be submitting your homework to me electronically. So that means that however you produce your homework, whether it's by hand or Overleaf or whatever, ultimately you're going to need to produce a PDF file. So somehow you produce a PDF file. If you're scanning handwritten work, there are various apps that you can put on your phone, including Tiny Scanner, that will help you scan a file to PDF. Now, our exams are going to be taken on Canvas, and they're going to be proctored using Respondus Lockdown Browser and Respondus Monitor. Now, Respondus works well with a variety of formats, but it doesn't like Chromebook. So if you have a Chromebook and you don't have any other way to access Canvas, then it's probably a good idea that you contact me ASAP. There will be a practice quiz in week 5 in which we all become familiar with how to use Respondus Lockdown Browser and Respondus Monitor, and then we'll all be ready in week 6 for the first exam. Finally, any virtual meetings that we have are going to be done using Zoom. I'd like to finish with kind of a fun application of group theory. Now, many of you have done Sudoku puzzles, and when you finish your Sudoku puzzle, you wind up with a fairly special grid of numbers. Now, in an ordinary Sudoku puzzle, when you finish it, you wind up with a grid of numbers, the numbers 1 through 9, where in the grid there's no repetition of numbers in any row, in any column, or in any of the 3x3 tiling regions. Now, the grid that you are looking at on the screen is a 12 by 12 grid, and the numbers, instead of being 1 through 9, are going to be 0 through 11. And you might notice that in this completed grid that there's no repetition of symbols in any row or in any column. And even further, you might notice that the grid lines serve to divide the square into 3x4 regions, and that there's no repetition of symbols in any of those 3x4 regions. And then the colors serve to divide the array into 4x3 regions, and you might notice that there's no repetition in any 4x3 region. So we call this a 3,4 super Sudoku grid. And, you know, if someone just handed you a blank grid and said, well, why don't you write down for me a 3,4 super Sudoku grid, just write down an example, that might be a hard thing to do if you just start with a blank grid and a pencil in your hand. It turns out that sometimes in constructing grids like this, it can be helpful to have some arithmetic structure in the background. And in particular, there's a group called the alternating group A4. That is, it's this special set of order 12, and it has a nice operation on it. And you can use the structure of that group to produce a super Sudoku grid like this. In fact, this very grid that we're looking at was produced using a group. And as I said earlier, it might be very difficult to produce a grid like this just from scratch without any sort of structure in the background. So later in the course, when we're talking about the alternating group, perhaps you'll remind me about this example, and I'll talk more about it then.